Okay, everything's still okay. We're good. Oh, hey guys, didn't see you come in. So I was just wrapping up some things there with my construction here up at eSchool, and I'm actually glad you guys stopped by because it's a perfect opportunity for me to maybe step away for a little bit, let some things cool off, and maybe talk a little math with you guys instead. Man, it's been a lot of work, but me and old Rusty here, we've been figuring things out. So I appreciate you guys joining me here today. And we got a couple things we're gonna go over. We're gonna kind of continue some of the work that we did in a previous lesson, which is all about finding the area of these different rooms, right? So we have these rooms here that we're remodeling here at eSchool, and we want to be able to find the area of them so we can lay some tiles. And we were working with some manipulatives, right? And we had some rooms here, and we were like laying some things out to be able to find the area. And we came across some fractions, and even though that made us a little bit nervous, it was okay because we figured out that we can still multiply these fractions and still figure out what the area to a room is based on that. So so let's jump in. Let's do a little more practice with this in this lesson, and let's really wrap our minds around how finding the area of a rectangle could work using square units, and even if we come across some like fractions and different things like that and mixed numbers and all that kind of stuff. So again, today you're going to find in the module or in this video, you're going to find some rooms that you can print out again. You'll have some more of these unit cubes or unit squares if you want to print them out as well. If you still have them from the previous lesson, you can use them again. Make sure you have that stuff ready to go. Make sure you have something to write on, something to write with, because we're going to be doing a little bit of math too. And that should be enough to get you started. So once you have those things and you're ready to help me out with some construction, go ahead and click continue. I'm going to go ahead and grab a fire extinguisher just in case, but I'll meet you guys back here when you're ready. All right, guys. Well, thanks again for your help. So we're gonna roll through a couple things here because I've been doing such an awesome job with this tile, as you can tell, that eSchool is asking me to do a couple more rooms. They've kind of expanded their order of what they want. So I could really use your help because some of these rooms coming up here are definitely some unique sizes going on. So I appreciate you guys wanting to do some math with me on these things. So let's take a look at room A, okay? This is another rectangle that we're dealing with here. And again, I could model how to find the area of this rectangle again by laying out my cubes, my units here, my pieces of tile, right? And to figure out what my area is and how many pieces of tile I'm going to need in order to fill this room, right? In order to do all of the floor. So what I'm gonna do, I'm gonna just start laying these tiles out here. You can go ahead and play along with me at home if you're there, so we can work on this together. And it looks like here I'm not going to be able to fit a whole tile, so I'm going to come up here. I'm just going to finish with my whole pieces first, and then I'm going to come back and figure out what I need to do for the rest. And what it looks like to me, I'm going to run into the same issue on this end, right? Not going to be able to fit a whole tile there, but that's okay because we had that tile that we had folded into halves, into fourths. So I'm going to try this guy out and see what else I can fit. It looks like this is going to be perfect for my halves here. So I'm going to use that here. So I'm just going to put those half units there, and that'll fill up the bottom nicely. Beautiful. And then, would you look at that, my half tiles are going to fill up that pretty nicely as well. But I run into a bit of a conundrum down here, a bit of an issue because it's really not fitting either half or fourths. So, what can I do there? What am I going to end up having to do there in that corner? All right, well, if I take my square here and I'm going to fold it in half, and put it up there. Well, it would fit that way, but not this way. So let me fold it in half the other way. So I folded it like this way first. So I'm going to fold it this way now. So now again, I have fourths, right? 1, 2, 3, 4. They're just going in two different directions instead of straight like my other one was. So if I put this in there now, look at that. I know it's not perfect based on my tiles all being a little bit wonky there, but it's pretty good there as far as a fourth goes. So I know that this is going to be a fourth. It's not going to be a half, it's not going to be a whole, it's actually just going to be a fourth, which is kind of cool. So this is an odd shaped room, at least odd as far as not being even standard numbers here, but we do have some fractions and some mixed numbers going on, and that's okay. Like, we're totally cool with that. We're going to be able to figure this out. So let's go ahead and look at what we have here. I'm going to label this rectangle a little bit, just looking at it, looking at this room. We're going to say that we have 2 1/2, right, going down this side, because I had 2 full units, 2 full squares, and then a half of one down here. So this guy's going to be 2 1/2 on this side. All right, and going across the top here, I have 1, 2, 3, 4, 5. Oh, but that's not a whole one, is it? So I have 1, 2, 3, 4. 4 and another half. So 4 and a half. And then going down this side, I have 2 full ones. Even though these are halves, the side of it is full, okay? And then I have a half of one down here. Even though this one is divided into fourths, lengthwise or widthwise, like along the side here, it's 2, 1, 2 and a half, okay? Hopefully that makes sense. Then across the bottom we have the same measurement. Since it is square, since these are 90-degree corners here, our sides are going to be the same. They are parallel. They are the same distance, okay? So 2.5 and 4.5. So that's perfect there. So what I'm actually going to do here, I'm going to count up my whole tiles, right? So I have 1, 2, 3, 4, 5, 6, 7, 8. And I'm just going to go ahead and kind of draw out these whole tiles here. Okay, so here and woohoo, that is a wavy line. Okay, but you guys get the idea. So there's my whole tiles there. This is my entire rectangle. We'll kind of do that with a solid line here. And yes, this is not the best drawing ever. I am an artist, I know, but today I'm a little tired from all the construction we've been doing, so it's okay, we're getting the point across. So those are my whole tiles there. And if I look, here I have 1, 2, 3, 4 by 1, 2. So to find the area of just this spot with like these whole tiles here, I had 4 times 2, which gave me 8. So this is 8 units squared. All right, that's cool. So let me see if I can figure out these other guys. So really I have another kind of shape in here, right? I have these 2 whole right here, and then it's a half the other way. So really if I did 2, 1, 2 and a half, or 2 times 1/2, that would give me, well, that's going to be 1 whole right here, right? 1 unit whole, or 1, I'm sorry, 1 unit squared, but there's 1 whole of them. If I put those 2 halves together, I'm going to get 1 whole. Down here, we have a half, a half, a half, and a half. So I have that half 4 times, which would be equal to 2. And if you see, if we put those 2 and 2 together, that's going to give us 2 whole there. And then over here, we just have our quarter, right? This guy is just 1/4. So what we have here, I have basically, like, if you remember back to multiplication, we have like partial products here. We have part of our answer, part of our area. We don't have all of it, okay? We have 8, 1, 1/4, and 2. But if I take these and I add all those numbers up, that'll tell me the total area of this entire rectangle. So I'm going to go ahead, I'm going to move these squares out of the way just so we can see a couple things. Okay, so I got my squares out of the way, and so now we can see like the shape inside the shape, okay? So I have my 8 units here, I have my 1 unit here, my quarter, and my 2. So if I take those and I add all of those up, 8 plus 2 plus 1 plus 1/4, I'm going to get, well, 8 and 2 is 10, plus 1 more is 11, 11 and a half. I think I said 1/4 before, but I meant a half. So this is going to be 11 and a half. So that's going to be the area of that entire shape. But I was able to, instead of doing 4.5 times 2.5, I was able to find like each little piece, the area of each little piece, and then add those pieces together to get my total product, my total area. So that's one way we can do it, using like drawings, using manipulatives, using shapes to be able to lay that out. We can also do it the mathematical way though, right? We can get a formula going and we can just do the math behind it, right? So what I'm going to do is, I'm going to have that original work we did, I'm going to keep that in one window, and then here on this paper I'm going to do the same sort of thing, just using the math behind it, okay? So we know we had that rectangle, right? And that rectangle was 2.5 units by 4 units. I'm sorry, by 4.5 units. All right, and throughout all of these, when I'm saying units is kind of like a stand-in for any measurement. This could have been centimeters, this could have been inches, this could have been feet, it could have been meters, it could have been kilometer, it could have been whatever. But units is just kind of like a generic term. That way we can kind of understand this a little bit better, or at least what we're getting at, right? So let me go ahead and write this in a little bit darker so maybe we can see things a little bit better. Nothing like a Sharpie to really kind of bring things together. All right, so this was our 2.5 units. it's 4.5 units. And there we go. So we're getting this to come together. So if we did the actual math behind this, so basically I would have 4.5 times 2.5. Okay? 4.5 times 2.5. And if we're doing this, we're basically combining all of these numbers. Like we're going to be doing 4 times 2, and we're going to add that to 4 times 1/2. And we're going to add that to 2 times 1/2. And we're going to add that to 1/2 times 1/2. So all of these numbers basically are going to have to hit each other or interact at some point, okay? Which is what we did in that layout when we did all those partial products there, and we did our 4 times 1/2, we did our 2 times 1/2, we did all of those things there. We just did them in each square to kind of keep it organized that way. We could also do it mathematically just like this. We just have to know each one of these numbers is going to hit the other number, okay? And then we can kind of use this expression down here in these parentheses to kind of help us map us out and where we need to go and make sure that we are doing that, okay? So we could do 4 times 2. That's going to give me 8. So I'm going to have 8 plus 4 times 1/2. Well, that would be 4 halves, and 4 halves is the same as 2. Okay, plus 2 times 1/2. Well, 2 times 1/2 is equal to 2 halves, which is equal to 1 whole, plus 1/2 times 1/2, which would be, well, 1 times 1 is 1, 2 times 2 is 4, so that would be 1/4. So which is what we had in our original figure, in our original rectangle there. It's the same thing. This is just kind of writing it out. Remember, we had those shapes kind of like this, right? And this worked out to be 8. This worked out to be 2, 1, and 1/4. Okay? So we add all those together. We're going to get 8 plus 2 is 10, plus 1 more is 11, plus the 1/4 is 11 1/4. Perfect. So same sort of thing, same sort of idea. Whether you're comfortable doing it this way, finding your partial products, basically breaking apart the 2 and the 1/2, the 4 and the 1/2, and then working it through that way, or whether you want to write it out here as an expression, either way is totally valid and is going to help you get to the right answer. Now, as you go through these rooms today, because I'm going to have to get back to work here eventually, they're calling me down the hall, they're yelling at me for different stuff, so eventually I got to get back to it. But as you go through these different rooms today and work these out, you may encounter some rooms that are relatively small, right? And you're going to have to use those tiles that we folded up to help you figure out what those distances are. And it might not be a mixed number. It might be just a fraction on its own, or it could be a mixed number. It could be a combination of the two. Some, like I'll give you a hint, if we look down here at room E down here, this one doesn't really fit quarters or halves or anything like that. So he might be another fraction altogether. He might, or she might, or it might have to be thirds. So if you want to get thirds, you got to kind of overlap your paper there evenly, fold it through, and then, oh, would you look at that? It's going to match up to my thirds. Okay, so I'll give you kind of a hint on that one. So I'll let you guys work through that one, and then just think about how you would solve these. If you end up with two fractions that aren't mixed numbers, multiply the fractions. If you end up with a mixed number and a fraction, or two mixed numbers, just remember we got to multiply all of those parts. Okay, we got to do the 4 times the 2. We got to multiply the whole numbers together. Then we got to multiply each whole number by each fraction, and so on and so forth. Okay, so hopefully that helps get you started. Like I said, I got to get back to it. They're shouting for me. I think I see some more smoke coming out of that room, so definitely got to get there with the fire hydrant. But I appreciate you guys watching and playing along. I appreciate you helping me out as you work through these different rooms. And please let me know if you have any questions, comments, or concerns, or an extra fire hydrant, because I got a pretty good idea we're going to need that. So thank you guys for watching. I appreciate all the hard work you're doing. I'll talk to you soon. All right.